Good morning. I'm going to go over this worksheet, ionization energy data table, and we have a graph here that's already done, and then we have a blank data table down here. Now, ionization energy describes it here, but what ionization energy is, it's the amount of energy required to remove an outermost electron, or like a valence electron, from an element. Some elements hold on to those outermost electrons more tightly than others. And you can see just in the first examples, we have hydrogen down here, which is the first element, and then helium up here. So helium holds on to its outermost electrons much more strongly than hydrogen. It's easy to remove that one from hydrogen, much harder to remove it from helium. And then you'll notice that it goes, these are all in order, right? These elements are all, first, second, third, fourth, fifth, sixth. And you notice a trend. After helium, it goes back down and then slowly climbs up till you get to neon. Well, helium and neon and argon, these are all to the far right of the periodic table. These ones at the bottom, hydrogen, lithium, sodium, these are all to the far left. And we'll talk about electron orbitals and electrons a little bit more. But in this, what you're doing is you're looking at the graph and you are, as best you can, approximating the ionization energy for each one. So if we look at hydrogen, we have the ionization energy in kilojoules per mole right there. And it's above 1200. It's not at 1600. And it looks like it's going by increments of 200, right? So this one would be 1400 in between. Closer to 1400, I'm gonna say 1350. And yours might be a little different, but it should be close to that. And then if we look at the helium, helium's all the way up here, but it's below the 2400 line. If we're going by 200s, that would be 2200. So this one, I'm gonna say 2350. And you're gonna do that for each one of these, just getting the ionization energy of each one as close as you can. Again, yours might be a little different than mine, but it shouldn't be much further off because it's a pretty well created graph. All right, let me know if you have any questions. Thanks.